Consider an application like this. We have a PV panel, PV source, which is connected through a power converter, and the output of the power converter is connected to a load. This is a typical application. No batteries are used. Now, there are many applications where the load may demand a very steady power. But the power that is coming from the PV is highly fluctuating. We saw that because of the insolation, because of varying insolation, the output power here is fluctuating. So in case the load is demanding a steady power source, we need to have an energy buffer somewhere here so that the PV can charge up this energy buffer, and the energy buffer can supplement the PV source by providing a steady source of power input to the load. So in general, there are many applications where there is a charger, which is again a power electronic converter, and it charges up a battery or any energy storage device. So assume that this is a battery, and the power can flow into the battery for charging, and it can also flow out of the battery while supplementing the PV source when it is weak, so as to make up for the load power requirement. Now this battery is the one of interest, and we want to look at some detail into the various types of batteries and its characteristics. The battery here is acting like an energy buffer. Now the batteries are of two main types. One is the primary cells, and the other type are known as the secondary cells. Consider the primary cells. The cells that are used for torches, clocks, remote controls, watches, they are all primary cells. The main feature of the primary cell is that they can be used for only one discharge. Some of the examples are zinc manganese oxide, also called the dry cell, zinc silver oxide, lithium thionyl chloride. These are some of the primary cells. And the most important feature that you should note in a primary cell is that primary cells can be discharged only once. This is the key feature, and after they are discharged once, after they are used once, you have to throw them away. Secondary cells, on the other hand, can be charged and discharged several times. Car batteries, two-wheeler batteries, UPS batteries, these are all examples of secondary cells. So lead oxide is more commonly called the lead acid battery. The acid here is sulfuric acid, dilute sulfuric acid. Nickel metal hydride batteries, lithium sulfur dioxide batteries, lithium-ion polymer batteries. These are very popular batteries, lightweight, and are now very popular and almost ubiquitous. You will find them in almost all the electronic gadgets, cell phones, iPhones, iPads, laptops, camera, video cam. All these devices use these lithium-ion polymer batteries. These batteries, as I mentioned earlier, can be discharged and charged many times, several times. They can be discharged from 100 times to 20,000 times depending upon the type of the battery. So this is one major advantage of the secondary cells. For photovoltaic based systems, most of the applications will use only secondary cells. There will be several charge discharge cycles, and secondary cells are the ones that are most compatible for these applications, and we will be discussing the secondary cells, their characteristics, their features, the parameters, and how we go about charging these secondary cells are the ones that we will be discussing in some detail in a short while.